so the mysterious clicker. We'll see what happens with this one. Well, it's actually good afternoon now, everyone. Before I start, just for me being a BGP guy, Ulsa's presentation was one of the best that we saw on the PC when we were doing the review. It was just fabulous because it's exactly the things that I've spent many, many years teaching. And to see this being implemented like this, it's incredible. It really is how a lot of this work has to be done. And I really enjoyed it. It's nothing to do with my presentation. Well, maybe it is just a little bit. Just a little bit, and you'll see why. Because to do some of that research work that Ulsa did to work out how to use all these BGP communities, he and his colleagues will have had to use tools like this. I mean, I popped it into the program just as a, well, if you've got space, maybe we can talk about it. And actually the PC member said, no. Very few people in Mongolia actually know about looking glasses or even the facility that RouteViews offers. So we can actually cover it in the program here. Yay, it works. So what is it? It's a collaborative router-based looking glass where we can all log into and have a look at what the global routing table looks like. We can look and see what our routes look like in many different parts around the world. It's used by network operators, so all of us can log in and use it. It's used by researchers, so people like Jeff. I do a little bit of internet research as well, but many universities and other internet researchers will also use the facility on RouteViews. And I'll show you some of the things that it can actually do as we go through. Founded at University of Oregon's Advanced Network Technology Center, 1995. So archives actually go back to 1997. So you want to see the internet in 1997, at least how routing goes, RouteViews has that. 22 terabytes of data. Please don't download it all at once, but you can download it and have a look at how the internet looked for probably the last 20 or more years. So the group is currently led by the network engineering team at the University of Oregon. Hervé mentioned University of Oregon Network Startup Resource Center earlier in his talk, so I won't really need to mention that. But University of Oregon, the campus network team leads this effort with assistance from a few others. Hervé talked about NSRC and he also mentioned University of Oregon. Hervé and I were walking with Tashi around Ulaanbaatar yesterday, and we saw somebody with University of Oregon logo and also the college American football team wearing a sweater, so Hervé felt at home. So these are the two. I didn't ask them about using their photos, but I don't know if David will be very pleased about that one, but anyway, that's all he has. And Eric Smith are the others, no relation. That picture is no good, but probably better to do it from this point of view of showing where the collectors are. These collectors are all around the world. If you want to, you can go to Sao Paulo in Brazil and see what Mongolia internet looks like, if you want to. You can see if Mongolia routes are there. How do you get from Sao Paulo back to Ulaanbaatar? And many other places. Actually, and I will talk about this in the workshop in the next 5 days, you can look at the RouteViews locations at the URL there, at a facility called the Peering Database. Again, that's another collaborative website where network operators put the peering information on the website. So you can find all the locations where these collectors are. And notice, most of these locations are internet exchange points, where many network operators will interconnect their networks. There's no RouteViews in Mongolia. So if you're interested, let Hervé know. I'll pass the buck to Hervey, because Hervey is Assistant Director at NSRC. So peering stats, about 314 million prefixes, 833 peering sessions. This is a few months old. I'm sure it's increasing. 239 different autonomous systems are visible there. Now, the internet today is 65,000 autonomous systems, but these are how many that actually peer with RouteViews. And we always look for more, because it keeps the researchers and the operators happy. What it runs on? It runs on two types of systems. So one type would be commodity hardware, 8 to 16 core server, 32, 64 gig RAM, usually gigabit or 10 gigabit Ethernet, running things like Linux, CentOS, Quagga, BGPD, or FRR, also the BGP software there. So it runs on any simple PC hardware with the right spec. There are also some instances which are running on Cisco's ASR 1004 router, running Cisco's iOS software. So some of the RouteViews connections use something called multi-hop. You set up your router to talk to RouteViews at University of Oregon. So that's not a direct BGP session, but crosses many other networks to get there. The nice thing is, you can provide RouteViews with data. The downside is, what's hiding underneath in the path to get there? And researchers are very often interested in the path to get there. So RouteViews prefers to go to an exchange point to plug in the small server and collect the BGP data from there. Data is exported using something called MRT. This is the multi-threaded routing toolkit. RIBs are dumped every 2 hours. BGP updates are dumped every 50 minutes. So you get quite good resolution about what's happening on the internet. These files are compressed and then sent back to the archive. And the archive is the big 22 terabyte repository recording all the routing information that RouteViews have collected. And you can access that using HTTP, FTP, and rsync. There are many tools that will read MRT data. Humans can't read MRT, well, at least not easily. But there are many tools that have been developed by the community. We've listed some of them here, there are probably more, where you can take this data and transfer it into something that you can read. To get access to it, you can log in. Most of the RouteViews instances, you can just use Telnet. Very simple Telnet, the RouteViews instances that I listed earlier. And once you're logged into the device, whether it's a router or FRR or BGPD, OpenBGPD, you can run the simple show commands like this. And I'll give you some examples in a minute. Some people say, ooh, naughty, naughty, should not be using Telnet. Okay, that's loud. Right. It was the Telnet people saying, don't use, but we have nothing to hide, right? Should be using secure shell. But the Telnet access, there's nothing to hide, it's a simple open collector. Okay, I'm afraid of these. I'll stay here, right? Actually, they use secure shell for management access for the device, but the general users will log in using Telnet. It is those. So, how it works, BGP is the backbone of global routing infrastructure. So, to ensure stability, we have to watch it. As you saw in Ulsa's presentation, Mobicom are watching what their routes look like, what their connectivity looks like all the time. Monitoring the network is vitally important. Amazingly enough, we have a network management and monitoring workshop for the next 5 days, because monitoring is one of the most important things we need to do. Right? So to ensure the stability of the network, we need to monitor the routing system. RouteViews lets you log in, command line login. Prefix visibility, convergence, path stability, compares local view with regional views and the global view. What does the route to you look like from different parts of the world? For my use, it's mostly troubleshooting. In all my travels and the BGP workshops I teach, I use RouteViews for troubleshooting. I don't use any other ones because this is easy, it's a command line, very, very simple to drive. How to access the collector, you look up all the names. I mean, here I can log in. This one at Links is in London. There's one in Singapore, the long list that I showed you earlier. You can just log into them. There's some of the list, and look at what your routes look like, or other people's routes look like from those locations. So here's some examples. That's why the slides didn't go onto the laptop until now, because I was doing some of the examples from this room. I'm just curious to see what the internet connection looks like. So here's a login. The SG is Singapore. I went to the Singapore RouteViews, and these are all the neighbors. If you look at prefixes received, some of them are giving RouteViews the full BGP table. Oops, not that one, right? Full BGP table down here. Others are just giving their peer routes, the routes that they see from their network and from others they peer with. But this gives us a very good idea of what the reachability might look like from this system and then through some of these particular autonomous systems. Yes, so this prefix. So I go to RouteViews. I don't know if you looked. 192.82.65 is being used for the network right here in this room. Okay, you have a private address space, but somewhere Univision is translating to the public address. And that's what we're using here. So if I jumped onto, I don't know which RouteViews somewhere, but I see, this was one of the paths I saw, and you see things like this. The router does not know what this BGP attribute is, probably because it's running older software, but I can see the path. Here is another one. Right, so Univision, gone to Gemnet, wherever, 1299 Telia. I have no idea who 8283 is. Right? And you see another path. There are many, many more. In fact, it says there are 32 paths on this view. And you can look at the path you see with each one. I just put 2. Otherwise, you cannot see it on the screen. What else have I got? I need to point the pointer.
It just reflects your.
Woo! Okay. Did I blank? What did I do? Let's try again. There we go. This prefix, or this one, is I picked up at random. So I see things like, these are some BGP communities. I don't know what they mean. Maybe they're from AS4901. Here's an extended BGP community and that one down there. So you start seeing some of these interesting things. What's interesting about this one, we've got some of these communities, and then we see communities of the next, right, 3356. Look in the S path, it's these people. So the prefixes from AS3356 are being passed on to AS101, who's then passing them on to RouteViews. So there comes a question, should network operators be passing on communities that they learn to other operators? My answer would be no, but who knows? What else? I'm really doing something with this pointer. I don't know what I'm doing with the pointer. Try again. I think it's trying to suggest that it's lunchtime. Can you do the next slide? This is not doing anything. Yeah, you can't read this, but I'm looking at this destination. In fact, I can't read it either. 194.126.81.35. But I'm looking for all the paths of that particular destination. Sorry, you can't read it. Yeah, next one. Yeah. Here's another one. This is, again, to this network. So here, all the paths to mnNOG conference venue in Ulaanbaatar. You'll see this when the slides go on the web page. You'll be able to read it better. But again, we see all the different paths. So Univision, GemNet, pretty much all of them. And then you see GemNet's upstream providers there. So we can see it through different paths. Oops, now it's working again. Let me go back one. Yeah, back one. Yeah. I've done a trace route. So here's the trace route to mnNOG. So from mnNOG to just my home in Brisbane. So we go wandering through local networks here, and then it pops out PCCW Global, going by the round trip time, wherever, over there, it's Hong Kong. So about 60 milliseconds away, crosses the peering at HKIX with Internode, my ISP in Australia, and then down to Australia. So from here to Australia, I'm seeing about 220 milliseconds. So I've checked the way out. I could go, this is Sydney. So I could go to Sydney RouteViews and find the way back. But I didn't do that because it ended up being break time this morning. But you can start seeing, checking the path out, checking the path back to you. Yeah, next one. This one I picked up from another conference. I don't remember who it is. But this was an IPv6 network. /32 is what people get for IPv6. And they've decided to take the V6 and chop it down into 48s. So if you do your arithmetic, you'll know there are 65,000 48s in a 32. So if they carry on doing this, the V6 routing table will get very, very big. So we don't know why they're doing this, but it's there. This was an interesting one. This is a troubleshooting one, I think. Or is it troubleshooting, or is there a problem? Here's a RouteViews for a /19 prefix, 32 paths to this aggregate. But next slide is interesting. Tashi knows this one. This one is interesting because they leak this /20 for traffic engineering at one exchange point. One exchange point in Asia. And it's only for traffic engineering in that one exchange point. I'm on RouteViews. I see this prefix being transited by a certain large operator who shall remain nameless all around the world. Right? So we can't even use subdividing address space for traffic engineering if we connect to them, because they will happily tell everybody around the world. So this has really messed with this operator's traffic engineering. What also was talking about is what they need to do. Tashi and I have explained to them that they need to do it, but they're not doing it. So maybe, Ulsa, you can come to Bhutan and you can help fix this. Where's the next one? What was this about? Yeah. Jeff asked the question of the previous speaker, does ASPath prepend work anymore? Ulsa said no. These people seem to think it does.
Well, they're trying. 26 is a good try.
26 prepend, and those are small. I've seen them up to 250. What do those do? So you can see the fun right down here. It says best. And it's still huge prepend. It's fun looking at a lot of this. Is this a hijack or misconfiguration? Here we have a prefix. It's originated by 38201. Okay, it's originated by 38201. That's the aggregate. This is correct. But we go to the next slide. First subnet, right? So traffic engineering, they take aggregate, divide by 2. Traffic engineering, this is in the Pacific. They have one link to Australia, the other link to the US. Same issue we have here in Mongolia. One goes east, one goes west. Divide by 2, they want to send one to the east and one to the west for whatever reason. The next slide is the other subnet. It's originated by the upstream provider. So the upstream has just decided, oh, I'll take their address space, I'll take a piece, and I will announce it. That might be okay, or is it? Right? This is the upstream provider has just unilaterally taken this address, the 21, divided into 2 pieces, announced 122. It actually has implications, because with Tashi's talk right at the start of the session, here's the prefix. And this thing means it's an invalid origination. It belongs to them, but it's been originated by these people. Yes, right, the upstream. Sorry, by Fiji International Telecom. It's been originated by their upstream. So it's an invalid. And Tashi was saying, listing all the providers who drop invalids. And so Tonga Communications were writing to me and saying, our routing's not working properly. Everything goes to the US. Even when I try and get to Australia, it goes to the US. Because this thing was causing havoc with, no, sorry, it's the other way around. This was causing havoc somewhere in the US because of the invalids being dropped. So RouteViews can be used for that. I can go on and on and on and on with lots of examples I've collected. But for each NOG, I try and give some of the interesting ones. But BGP anomalies and dynamics are very critical as well. So RouteViews do network topology monitoring, route leaks, network optimization, all this. Not to mention the many research publications as well. It's too many to mention. A lot of these organizations will host our server for free. As I said at the start, if you're interested in hosting one here, we like hosting at an exchange point where every operator is present. So if you are interested as a community in general, talk to Hervey or talk to me, and we can put you in touch. And that's it. Given it's almost lunchtime, I would suggest if there are any questions, maybe we talk at lunch. If you come to the workshop tomorrow, we can talk a lot more about this as well.
Okay, thank you, Philip. Асуулт асуух хүн байгаа юу? За, асуулт асуух хүн гээ. Thank you, there is no question.
That's good.